DNS zones. Yes, we are going to talk about DNS zones today. Hello, friends, and welcome back. A DNS zone is a collection of a DNS resource records, like one that map contoso.local and its IP addresses. Okay, there are two main type of DNS zones: forward and reverse lookup zones. Forward lookup zones are the most common and translate host names to IP address. A reverse lookup zone is the exact opposite because it translates IP address to host names. As I mentioned, a forward lookup zone translates a domain name to an IP address. We can ask from a DNS server for an IP address of a host name, let's say DC01, and the DNS server will respond with the IP address of that DNS host name. As an example, we can go to command prompt and do a nslookup for DC01. Now, this would be an example of a forward lookup. Again, a reverse lookup converts an IP address to a host name. So, let's say if we need to find a host name of the IP address of 192.168.100.5, then the DNS server will query the reverse lookup zone and provide the host name of that IP address. Now, both forward and reverse lookup zones can contain primary, secondary, and stub zones. A DNS server hosted in the primary zone is the primary source for information about this zone. By default, the data for this zone is located in the file in the Windows directory /system32/DNS. This file may also be stored in Active Directory if this DNS server is also a writable domain controller. And there are some benefits and reasons why you want to store a primary zone in AD. Since this zone is stored in AD, it can be replicated using Active Directory replication process. It is important to keep in mind that the primary zone is the only zone type that can be directly edited or updated. Now, secondary zone is a read-only replica of a primary DNS zone that is hosted on another remote DNS server. This means that your DNS server must have network access to remote DNS server in order to gather the information. This DNS zone is not stored in AD because it's just a read-only copy of a DNS zone. If you try to update a record to the secondary DNS zone, the change request will be passed on to the server which holds the primary DNS zone. If the server is available, the update will be made. The purpose of the secondary DNS zone is redundancy. If the server hosting the primary copy is unavailable, this server will be available for the client. But the issue of the secondary DNS zone is that each record held within the zone must be replicated from one server to another. On large networks that have frequent DNS server changes, this can be resource intensive. And a stub zone is similar to a secondary DNS zone, and that it is a read-only zone that obtains its information from another remote DNS server. The main difference between a stub zone and a secondary zone is that while a secondary zone contains an exact replica including all resource record of a primary zone, a stub zone only contains information about authoritative name servers. So, inside of a stub zone, you will not see any resource record for computer names, but instead record for other DNS servers. The purpose of this zone is to allow computers in one network to obtain information from a DNS server located in another network. So, this DNS server doesn't need to replicate all the data from other DNS server. So, we can take stub zone as a less resource intensive version of a secondary zone. Alright, so now you understand forward and reverse lookup zones. You understand primary, secondary and stub zones. That's all for this video. Thank you for watching and have a nice day.